with Adam presenting his results, and then we had a few avenues to explore. Hi, Marco.
Hello.
Hi, Marco.
If I remember correctly, I think a few avenues were to explore a few avenues with Adam, Samuel too, if I'm okay, and then somebody else in the chat. I don't remember who exactly.
It was Mario, I think.
Oh, Mario, yeah. Is he? He doesn't seem to be here.
Mario is not going to be here today. Like, he had some deadlines with some grant submissions and stuff.
Okay. So is there anything new on that front that somebody has tried? Adam, for example.
Yeah, I have a little bit of stuff I can say.
Mm.
Yeah, so last time I had this simple convolutional neural network that I was training with using the data that had already been run through the quantum circuit to produce the distributions, and then stacking those together for 6 different observables. And then we decided to simplify the problem of it by just reducing to 2 classes. And so that's what I did. Did the same training procedure and everything. Yeah, so this is the training curve from that. So still not great. I mean, we're reaching about 75% at most.
Mm-hmm.
So yeah, I'd say kind of similar to the last results. Yeah, so that's that. And then we also had this idea of creating sort of an ensemble classifier, whereby in training we process the images using a different observable for each class, and then in testing we process the images using each of the observables, and then run it through the classifier to get an ensemble of predictions, and then combine those into one. And this so this is the training curve. It classifies the training data quite well, given that it's from different distribution or different observables, but it really doesn't do any better than random on the test data.
Mm-hmm.
And I think that's more because it classifies more which observable was used rather than which class the image came from. And if you plot the accuracy of observable classification, as if the observable was what we were trying to predict, it does that very well for the test data.
Okay.
So yeah, this doesn't look too promising, really. And yeah, that's as far as I got, pretty well.
Mm-hmm. So in your second slide,
Here?
yeah, did you use the same observable regardless of, like, you mentioned here 6 observables. Did you use?
So this was using the same 6 observables for every class, and then just stacking the distributions together into an array, sort of, and then using, yeah.
Mm. Yeah. So not that conclusive in the end, I think.
Yeah, not really. And I'm not really sure if there's a way to kind of extend this or go more with the idea, or if it's worth doing.
So your observable do not commute.
Yeah, so I used just random observables this time, but I made sure they don't commute.
Okay.
Remind me, how do you compute the 256?
So I had this quantum circuit. Here it's in this quantum circuit, and it's just from measuring the 8 qubits.
Oh yes.
So yeah, 2 to the 8 is 256.
Because the last time we talked about PCA, principal component analysis, possibly. It's a way to reduce the dimensions of the data.
Okay.
And I've came across a paper where there are, I don't know if we can put it in a chat. It's going to be easier. Exploring ways to use quantum methods for PCA. I guess that could replace the first stage with a new circuit, possibly, but I didn't have a chance to check more on that.
Yeah, we did talk last time, I think, about trying various different quantum circuits. But yeah, I didn't get there yet.
Mm-hmm. I think it could be interesting to explore that, but also maybe read on some other directions to take. Because with the literature review that you did recently, Samuel, I think there are a few papers which are interesting that we could look into and maybe implement eventually.
Yeah. Maybe I could present one of the paper in. I think next time Mario is presenting something, I believe.
Yeah.
But it could be the one after. Maybe I could summarize the paper probably. It's a paper in Nature that was published last year about encoding.
Yeah.
So the Hansen classifiers, you're taking random representation and you're putting them. That's the way you're doing it. You're doing multiple classifiers, and is that correct?
Yeah, it's the same classifier. We just run it through with
Okay.
as the data processed with a different observable.
Okay. So a different random circuits for the first stage.
I said the quantum circuit is the same. We're just measuring when we measure the 8 qubits at the end, we just measure with respect in a different basis with respect to different observable.
Because maybe one way would be to, sometimes when we want to have a good representation, we try to increase the contrast between the representations, so the distance. Let's say you know your two classes are different, so you try to maximize the difference. And when they are similar, you try to diminish the distance between the representations. Maybe there is a way to train the first stage where it's not a classifier, just a distance, like we call that a contrastive metric. But I have no idea what kind of feedback we can have on the design of the first stage. I'm just thinking out loud.
Adam, do you want to make your network again?
Yeah, sure.
Sorry, Samuel, you were saying?
No, go ahead.
I just wanted to see it again, just to know if we could train some. Because right now your circuit, you don't train your parameters for your circuit, right?
There are no parameters.
No.
The rotation gates are not are fixed.
No, this comes from the data features.
Okay.
Right?
Yeah.
Yeah. Yeah, so that's the pixels of the image are fed in as the rotation.
Okay.
Would it be? Do you think it would be possible to have like some kind of variational approach to modify the parameters of the circuits, but using a cost function that would maximize the contrast? So the contrast is the difference between different classes should be maximally different, and same sample should be closer.
Mm.
Yeah, but I think you might need to know the answer in advance to know which observable you're going to use.
Okay.
Mm.
And how many parameters do you have? It's like how many
In the,
parameters exactly? You have the rotations and
so there's one for each pixel, so there's 64 by 64 images, and 3 channels, so whatever that product is. Quite a few.
quite a few, yeah. Okay, yeah.
Okay.
Yeah, so it's very difficult to get a good representation just shooting in the dark, basically.
Mm-hmm.
Yeah.
And do you see any difference with using just 2 classes? Do you see any improvement or not really? Because I guess you don't see the difference between 2 observables, so.
Yeah, not really. So this was like the same as I did last time, just with 2 instead of 10 classes.
Yeah.
And yeah, we're still getting, at most 74% accuracy.
Mm-hmm. Yeah, so maybe, like, do you see, Adam, anything else you want to try on this matter, or do you feel like it seems to not be working?
Yeah, I don't really see anything obvious to try. Yeah.
Yeah, so maybe if we explore the data encoding front, we could generate a new circuit and then retry this technique, maybe.
Mm-hmm.
But I think for now, we kind of like went through the question and explored it. You explored tons of different.
Yeah.
Doesn't be that great.
Yeah, I think we need to maybe step back, go back to the literature review until we get another idea and we start exploring again.
Yeah. Speaking of, do we want to go on the data encoding route, or is it more of a, QNN development or something like that? So, do you have any preferences? Yes, Charles?
It will be really interesting to go to the data encoding, because we see a lot of paper about hybrid approach. So like you start with the conventional machine learning and you fuse with the quantum machine learning like far at the end. But I know that in our part we are kind of interesting to see where did that go. And I think it would be nice to go and search for that.
Okay.
Explore that.
Mm-hmm. Yeah, we could do that. So, in that sense, there is the paper that I think the one you sent me, Samuel. I will.
Yeah, I'm trying to. I can post it probably in the chat.
I will be
put my hand on it.
So Samuel, if you could put it in the Q&A, I think some people don't have access to the chat for some reason.
The Q&A, yeah, you're right. Okay.
Yeah, thanks.
Forgot about it, sorry. Okay. That's this one, that's okay. Okay.
You can put the data re-uploading too.
Yeah.
It's another way to put data. I'm not sure.
Oh, okay.
So this one in Nature. I thought it was extremely well written for a beginner like me. So maybe I can, the next time I can present, so try to summarize that paper. I think I need to read it anyway. So
yeah, great. So that could also give us ideas to we want to try to implement. Yeah.
And also they gave like practical circuits that you can use for each of the approaches. Like so it's quite practical, I think. I don't know if they have code. I didn't check, but
okay.
But they tested it on black and white images, so MNIST and stuff like that.
Which I think is a good start.
Yeah, it's a good start.
We need to walk before we run.
Yeah.
Definitely. So even having new ideas, Adam, did you try different ansatz, different circuits, or were you more focused on the observable part?
When I was working on like the quantum dropout stuff earlier, I did try like a whole bunch of different circuits.
Yeah, I remember.
Yeah. Do you think it's worth exploring? Maybe instead of using a bunch of Marco's shaking his head, no?
Not your case, I don't think.
Yeah.
Because I don't think changing the circuits is gonna change a lot more.
Yeah, it could, but we don't know. And most of it doesn't change anything.
Yeah,
for QML.
Yeah, and it could be very specific to the problem or the classes you're testing, so it's not really generalizable. So maybe not. Yeah. So great. If everyone agrees, we could go more into data encoding. So as Marco said, step back. Whoa.
Oh, okay.
What happened? Okay.
I don't know what happened.
How does it feel to go back to the
classroom? So as I was saying, so go back to the literature and just read a little.
Yeah. Yeah, that's a good idea. Now, who's next?
Anyway, yeah.
So in 2 weeks?
Yeah, in 2 weeks. Could work.
I don't know.
Yeah, but I think in 2 weeks gonna be the break, the 1 week break.
Oh yeah,
I don't know how we say it in English, but
spring break.
Spring. No,
spring break, I wish, but not exactly. Fall break.
Okay, so maybe 3 weeks.
Yeah.
3 weeks sound good.
Okay. So someone would like to review a paper to present in 3 weeks?
Yeah, I can review the paper I just posted.
Okay.
I'll yeah, I need to read it anyway, so I can summarize it and see if we can find something that could help us for that specific problem.
Okay, sure.
And if Mario has something too in 3 weeks, then we could maybe share the time or take some time in the other meeting later on to mention.
Yeah, I think Mario will be okay with shifting by 2 weeks, I think.
Yeah, perfect. So great, we take a new direction, back to the literature, and then we go from there.
Okay.
Good.
Baby steps. Baby steps.
Baby
Yeah.
steps.
Sounds good.
Okay, so I'll see you all. We'll see you all in 3 weeks. And if in the meantime, Samuel, you get stuck with the quantum part or the math, you just let us know. You can have a small chat and see what happens.
Yeah. If I have a question, probably I will have some questions. Maybe I can send you my understanding of the paper. Maybe you can check it before I present it, and yeah, for sure I will have questions.
Okay.
That's a guarantee. Okay.
Perfect.
Sounds good.
Does anybody have anything else to add?
Thank you. Just I have a question, if possible, for the next session, next meeting. Can we have some details about the circuits which Adam used? Because I think it's interesting to me to know why you use this kind of the circuit, and just a little bit more go to the details just to understand what does this.
Yeah, I'll try to my understanding, which is not complete, but I'll try to go into the circuits. Also, it's my goal is to understand the implementation, not just the equations, which is another level. But yes, I agree. We should go into the detail if we can.
Thank you.
You're
Okay.
welcome.
Perfect.
Great. Well, thank you very much.
Thank you.
Thank you.
Adam.
See you next time.
Thank you.